Hey everybody, today we will work another problem out. It's going to be another solar transformation problem. Um, and it's going to be one of the problems that really, it's kind of simple one. So, so we have, it says that the problem statement says calculate the current calculate the current passing through passing through passing through so the 5 ohm resistor. Okay, so in the circuit shown below, right? Shown below. Right, so that is the problem statement. So we need to do a little circuit here. So it's going to be, so it's going like this. So like we have two batteries, like you have two batteries like this. So it's going from negative to positive. And right here we have the first the first resistor, and then we have a node here, and we have a resistor going down, and we have a ground. We have a ground, right? So, and then we have another resistor, and then we have another voltage source, like that, right? So we have our resistors, and the values are 10 kilo ohms. And I bet to say 5K. 5K ohms, right? So now this one right here, all of them, this is the 5K ohms, right? And this is 2K ohms, right? So this is the current I'm trying to find, is the one going down, and I will assign, doesn't have it, the figure doesn't have it, but I will assign the current going in that direction, right? Okay, so this is what I am looking at. This is what I'm looking for, right? So that I going in that resistor. In other words, if you put your meter, your current meter, in that resistor between ground and that, you will measure the current going through that resistor, right? But we have two voltage sources. We have a one here and another one here. The values for that is 10 volts. And we have 5 volts. Right. So there's a couple different ways that we could do this, but in this case, we will be using source transformation because, so we could do node analysis to solve this problem, but source transformation really help if you don't want to go through setting the equations, right? So let's do source transformation. Okay, first of all, in order to do source transformation, we need to transform, right? That's what it says right here. Transformation. We need to transform these two guys, right? So, so in other words, I can do a current between this and this, right? So, and that's going to be equal to I is equal to B over R, right? So B over R in series and that, right? with this in series, I'm sorry, the voltage source is in series with that resistance. So therefore I can do this Ohm's law, right? And I get that 10 over 10 is equal to 1 amps, right? Is 1 amp. Okay. Okay, I guess fair enough, right? So we got that. Now, right here, I get, again, I get I. You can call this I 10, 10K, and you can call this I 2K, right? Which is going to be equal to 5 volts, right? And again, if you want to do it step by step, you have 5 volt. So you have a volt over resistance, which is going to be 5 volts over 2 kilo ohms, right? Which is going to be equal to what? Which is going to be equal to 2.5 amps, right? All right. So now we have 2.5 amps, right? Okay. So now I have to rewrite this circuit again, and I have to put those resistors in parallel. This resistance in parallel with this, the current that I have here, and that resistor in parallel with this current, right? So it's going to be like this. So the direction of the current, right, like that, right? And then, because we normally would go from negative to positive, right? The current flow from negative to positive, we go like this. And then it's going to be, right, like that, right? So this is now the 10 kilo ohms. And then, so then this guy right here is the one that I'm looking for, right? So this is the 5 kilo ohms, right? And then right here I have a 2 kilo ohms, right? And of course right here I have a current, right? And over here I'm going that direction, right? So I'm going up. So I'm going up, right? So and that current right here is 2.5 amps. Right. So we have 2.5 amps in this side. Okay, so now we have 1 amp here. We can see now that we can add these two currents because now we have two in parallel, right? So that's a good thing about this. When we have two voltages in series, you can actually add two voltages. In this case, we have the current in parallel. We can add them, right? So adding those is going to be, the new circuit is going to be like this. So it's going to be like this. It's going to be 3. It's going to be 10K, 10 kilo ohms, right? And then and then it's going to be, that's going to be 5K, right? 5 kilo ohms. And then, and then right here is going to be, then this is going to be equal to 2 kilo ohms, right? 2 kilo ohms. All right, 2 kilo ohms. And the current source now, the current source, so we have 3.5 amps. And you can see now that this circuit is getting simpler, right? So now we have only one current source, and we have some resistors in parallel, and we have this guy. This is the one that we're looking for. We're looking for this I coming down in this direction, right? So technically, you have a ground right here. Okay, now I can actually combine these two resistors, right, in parallel. So R parallel, right, between that and that is going to be 10 times 2 over 10 plus 2, which is equal to 20 over 12, right? With that equal to about 1 point something, right? So so it's going to be 1.667. So this is going to be equal to 1.667 kilo ohms. Actually, yeah, kilo ohms. Right. Okay, now, so now, right here, right, at this point, we have this, right? So this circuit can be looked now only with the resistors, which is going to be 1.667, and it's going to be and then the 5K, and then the current source is going up, right? 3.5 amps. Okay, so this is the new circuit now, as you can see, right? So now this is the current that I'm looking for, right? And it's coming like this, and you have a ground lamp. Okay, so now I can actually use the current division to do that. So the current division says that the one that I don't care about is the one that goes on the top, right? Don't care goes on the top, and the one that cares goes on the bottom, plus the one that I don't care, right? So which one I don't care? I don't care about this, right? So this I don't care, right? But I care the current about going in that one, right? The current going in this one I care, right? This is the one that I need to find. So the current is going to be equal to 1.67, right? Times that is the resistor, right? Times the amps, right? Which is going to be equal to 3.5, right? Now, divided by what? Divided by the one that I care plus the one that I don't care, which is 1.67 plus right? And that is equal to approximately 8.75, which is equal to amps, right? That's amps, which is equal to 0.75 milliamps, right? So yeah. So that's how you get the current. And problem like this using the source transformation. Of course, you could use something else, right? You could use node analysis, right? But in this case, we're doing source transformation, so you get the same answer by doing source transformation, or you doing nodal analysis or mesh analysis. You know, any of those methods you could use. The only way that, well, source transformation is, it seems like it's easier because you don't have to set up the equations. But again, I guess it depends on the teacher, depending on what method you want. Do you think it's easy for you to solve these problems? But that is the answer for this problem. Thank you for watching, and remember that over here in this channel, Conservative Engineering Academy, we learn something every day because Jesus is great, right? So thank you for watching. I'll see you in the next video. Don't forget, share and subscribe, and give me a like in this video. Thank you for watching.